What is a mole? Amedeo Avogadro is the person who came up with a mole, but for many of us, this is what a mole is. Here's Amedeo Avogadro. That's a name I'd like you to remember. He's the guy who came up with a mole. He actually did a lot of experiments with gases, which we'll talk about later. What is a mole? Don't write down this number. This is a 6.022 times 10 to the 23rd is a mole. This is a mole with 4 significant figures. We're going to use a mole with 3 significant figures, so don't write that down yet. So what is a mole? A mole is like a dozen is. A dozen is 12 of whatever eggs or whatever it is you're talking about. We often use it with eggs because it's convenient to buy 12 eggs. But what would be a number we'd want to use in chemistry? It'd have to be a huge number because atoms, particles are very small. So the number we're going to use is a mole, and a mole is 6.02 times 10 to the 23rd. Please write this number down and know this is a mole. A mole represents particles, and it's also called Avogadro's number. Please write that down. So it's Avogadro, not avocado. All right, next. Now here's a mole with 5 sig figs. You don't have to write this down, but we could write mole to a lot of significant figures. Here's a mole 6.0235 times 10 to the 23rd. Now don't write this conversion chart down. I'll actually give you a copy of this when I give you your calendar. But most of what we're going to be doing is these conversions right here. We go from grams to moles and moles to grams. And also we're going to go from particles to moles. We'll use that part of the chart right there. So a mole is really 3 things, and this is extremely important, these 3 things you need to write down. One mole, and you can see here we've left off the E. This is an abbreviated version of a mole. We can also write M-O-L-E if you like writing it with 4 letters. A mole is the mass of whatever substance, and T stands for, guess what? Periodic table. So we're going to get the mass of a mole of any substance from the periodic table, and that mass we get from the periodic table will be the mass of 6.02 times 10 to the 23rd atoms, particles, whatever it is we're talking about. So, anybody know what this is? This is an element on the periodic table. This is the element sulfur. So what do we know about sulfur from looking at the periodic table? Let's look at the periodic table. Now yours is not this colorful, but you'll see a sulfur. If you have a mole of sulfur, you'll have 32.065 grams of sulfur. Now, if you look at your periodic table on yours actually is rounded to 4 sig figs. Yours says 32.07 grams of sulfur. Either one's fine. But if you have this mass of sulfur, you also have 6.02 times 10 to the 23rd atoms. That's how many atoms of sulfur you have. Next, water. Water's everywhere. Water's super important in chemistry. Well, let's say you have a mole of water. Well, how many particles do you have? Well, once again, you have 6.02 times 10 to the 23rd. Now, this one, you're going to have to do a little bit more than look at the periodic table because you have to include the mass of 2 hydrogens, and the mass of 1 oxygen. Now, we know the mass of 2 hydrogens. Hydrogen's got a molar mass of 1.008, so we'll just say that's 2. Oxygen has a mass of 16. So add these together, we'll get a mass of 18.02. The 0.02s come from the hydrogen. Grams in a mole. Because you could write it grams per mole or just grams. That's how much. That's a molar mass of hydrogen. So if you have 6.02 times 10 to the 23rd, and we could call these particles or molecules, and I'll abbreviate molecules MC, you would have, its mass would be 8.02 grams. And it also would have 6.02 times 10 to the 23rd particles or molecules in it. Let's do some other substances. Next one, CO2. If you have a mole of CO2, how much CO2 do you have? Well, you have 6.02 times 10 to the 23rd particles or molecules. But what would be the mass of that? Well, you just want to look at the mass of carbon. Mass of carbon is 12.01. Mass of oxygen is 16, but there's 2 oxygens, so we're going to change that to 32. So if you add 32 and 12 together, we get a molar mass of 44 grams in a mole of CO2. And if you have that mass, 44 grams, you have 6.02 times 10 to the 23rd molecules or particles of carbon dioxide. Let's keep going. This is fun. I hope you know what this is. This is NaCl, sodium chloride. So for this, we're going to have to add up 2 different particles, one a metal, one a non-metal. Sodium has a mass of about 22.99. So that's the mass of sodium. Chlorine has a mass of 35.45. So if we add those two masses together, we get a molar mass of 58.44 grams in a mole. That's a molar mass of 1 mole of sodium chloride. So 1 mole of sodium chloride, which has 6.02 times 10 to the 23rd. Now I'm going to use a different number here. It's not really a molecule. It's not an atom. It's really a formula unit. So I'm going to write FRU. So it's a formula unit because it's an ionic compound. So that's sodium chloride. Let's do some more stuff with this. First, let's do it with let's do some calculations. Those are always fun. So here's our example. Let's say we want to know how many grams are in a mole of a substance, like specifically 7.2 moles of N2O3. Well, the first thing we have to do is find what a mole of N2O3 would weigh. So we know we have to add up two nitrogens. Nitrogen's 14. 14 times 2 is 28. Then we have to add in 3 oxygens. Oxygen 16. 16 times 3 gives us a mass of 48. Now we add both these numbers together, and we get a total mass of 76 grams, and that's our molar mass of N2O3. Now, if we have 7 moles, it should weigh 7 times that. But we have 7.2 moles, so it's going to be 7.2 times that number, and here's how we set it up. First, we start with our known value, which is 7.2 moles of N2O3. That was what I told us in the question. Now we want to set up our factor label, and this is what one of the things about chemistry I enjoy so much. So our factor label, you'll put moles on the bottom because you want the moles to cancel out, and you put grams on the top because that's what you're trying to find. So generally for these first problems, what we're trying to find goes on the top. What we're trying to get rid of goes on the bottom because that cancels out. And watch this cool showing of how I factor things out. Boom! There it goes. Gone is moles of N2O3. So that is canceled out. Now we've changed moles of that to grams. So now we have to do the math. We have to multiply 7.2 times 76 grams. And we'll get a big mass, which is 547.2 grams of N2O3. Now, you know I don't necessarily like that because this number up here had 3 sig figs, so I'd probably want to say just 547. There, they've done it. 3 sig figs, 5.47 times 10 to the second grams of N2O3, just 547 would work for me. Here's a couple of other problems if you want to try. How many grams are in 0.72 moles of beryllium? And next one, how many moles are in 2.40 grams of nitrogen? The answers you should come up with should be 6.48 grams of beryllium, and the number of moles of N2 would be 0.086 moles of nitrogen. Hopefully those work for you. We're going to do two more problems. Here's our next example. If a tablet, now in these we're going to go from moles to grams, and we're going to also change moles to particles, both very important. If a tablet in a bottle contains 33 grams of ibuprofen, you may have taken this sometime in your life or at some point if you've ever had any swelling or inflammation. It helps alleviate that. How many moles, funny I decided to use the word alleviate. How many moles are in one bottle? So here's how you'd set it up. You'd put the mass of what you start with. Our given value is 33. So we've got the 33 grams up here. And I put the 33 right here. And this number, the 269, I got from getting the mass of 13 carbons, 8 hydrogens, and 2 oxygens. So added all those together, I got 206.29. And at the top, I put a mole. So the wonderful thing about it, when you do this, your grams are going to cancel out. So you see grams of ibuprofen cancel out, and your final answer is in moles, which is what we see there. Questions? Hopefully that makes sense to you. Let's do one more. Now we're going to change this number of moles, which you have here, to, I'm interested in how many actually particles will be in just a little 33 grams of ibuprofen. That's actually quite a bit of ibuprofen. So how many molecules of ibuprofen are in the bottle? Oh, this whole bottle contains 33 grams. That makes a little bit more sense, not one tablet. So you take the answer we started with, which is 0.16 moles of C13H18O2. And this time, I know, remember we had that chart we said Three things are always equal: a mole, 6.02 times 10 to the 23rd, and the mass from the periodic table. Notice I've got a mole here and a mole here. They cancel, and then at the top I put molecules. Now a couple things I would probably do different is I just use 6.02. We don't need to use 4 sig figs. And let's just get in the habit of saying molecules is MC. It's a lot quicker to write. So basically you need to multiply 0.16 times 6.02 exponent 23, enter, and you get this number right here. We'll just once again just say molecules. And that's it. Let me know if you have any questions. Make sure you bring your notes to class. Thanks.